According to a recent study published in the Journal of Applied Geodesy, earthquakes may reveal their imminent occurrence through various anomalies in the ground, atmosphere, and ionosphere that can be detected using satellites much earlier than previously thought. Developing early warning systems for earthquakes can be highly beneficial in preventing deaths and destruction. One proposed technique involves using satellites to monitor various physical and chemical parameters on the ground, in the atmosphere, and in the ionosphere, a layer of charged particles above the atmosphere. These anomalies are known as earthquake precursors. Although researchers are aware of these precursors identifying definitive patterns, known as red flags, that indicate an impending earthquake has been challenging due to the complexity of precursor interactions and their variability across different earthquakes and geographic regions. However, as researchers analyze more earthquakes using increasingly sophisticated satellite technology, these patterns are gradually emerging. Professor Medhe Kunzada from the University of Tehran evaluated various satellite data from the period leading up to and following the two earthquakes near the Turkey-Syria border on February 6, 2023. This included data from China's seismoelectromagnetic satellite CSESO-1 and the European Space Agency's Swarm satellite mission, which consists of 3 satellites. Strikingly, he observed anomalies in the surface temperature of the earthquake region 12 to 19 days before the earthquakes and anomalies in atmospheric parameters 5 to 10 days before the events. These atmospheric parameters included water vapor, methane levels, ozone, and carbon monoxide measurements. When Professor Kunzada investigated the anomalies in the ionosphere, including measurements of electron density and electron temperature, he found clear and striking anomalies 1 to 5 days before the earthquakes, the timing of these anomalies becoming apparent first on the ground, then in the atmosphere, and finally at higher levels in the ionosphere suggests that these signals originate from the ground and eventually become more pronounced in the atmosphere and ionosphere. Studying these events can pave the way for earthquake early warning systems. However, researchers will need to evaluate more earthquakes in the future to better understand these patterns. Using data from the CSESO-1 satellite, ionospheric anomalies were detected for the first time before the February 6, 2023 earthquake in Turkey, Professor Kunzada said. Investigating anomalies associated with multiple earthquake precursors reduces uncertainty in detecting true anomalies, which can be effective in creating earthquake warning systems with fewer false alarms.